Alright, hello and welcome to Exponent Rules Day 3. In this lesson, we are just combining all the rules together and throwing a bunch of problems at you. So, I guess the main thing I'd give you is there are a lot of rules to remember, but if you're not sure what to do, try expanded form. Okay, so in this example, it's going to be either x to the 5th or x to the 6th. If you can't remember, just think x squared is x times x, and x cubed looks like that. So that means you have 5x's total x to the 5th. Okay, similarly, if I take this problem, where it's a x squared to the 3rd, again, what do you do with the 2 and the 3 here? Well, I just think that little 3 on this 3 here means we have 3 parentheses, and in each parenthesis, there is 2 x's, so that's a total of 6. So that thing combines to x to the 6th. Okay, and obviously the rule technically here is that you multiply these, but if you can't remember that, expand it out. And then the only real exception to that is negative exponents. There's not an easy way to expand them. So negative exponents, just remember the rules are there as you flip them. So 1x to the negative 2 power is 1 over x squared. Okay, and that you just kind of got to know because there's no easy way to do it in expanded form. So anyways, here you go. And you can kind of ignore these questions at the top. These are only for kids that are doing this as an in-class lesson. Okay, and I would encourage you to pause the video and try these in your notes and then watch the video for the answers. Okay, so hopefully you had a chance to try them. So here's a negative exponent, and it just moves down or flips, however you want to think of it, so that it becomes positive. And then 5 to the 3rd power is just 125. And if you don't know what 5 to the 3rd is, obviously just use a calculator there. So we get 1 over 125. Okay, same thing here. Don't leave it with a negative exponent. So here it's just going to move up, right? And then it becomes positive, right? And at this point, we don't have anything left in our denominator except 1, which you don't even really have to write there. Okay, and then last one, this is a negative exponent, just a little bit different style. So this one just means flip the whole thing. So I'm going to flip it to x over x cubed, and that makes the exponent up top positive. Okay, and then from here, I would clean this up. So here we have sort of 1x on top inside the parentheses there and 3 on the bottom. So basically, you pair up 1x's and cancel out. So you end up with just 1 on top and an x squared on the bottom. All right, and then from here, it's a distributed rule. You kind of distribute in this power of 2. But if you forget that again, just write, we basically have 1 over x squared times another 1 over x squared. That's what this little 2 means. And that'll give us 1 on the top and x to the 4th on the bottom. X squared times x squared. Okay, so again, you can distribute it in, but I like just expanding it out. Or at least thinking about what it looks like in expanded form. Okay, next problem. Go ahead, pause the video, give it a shot. Okay, so there's a few ways to do this. You could move this exponent b to the 10 down. That's honestly probably how I would start, but if you're going to do the rules a little more, this one would be multiply the 9 and the 4. And then the rule here with these is you add the exponent. So that's just going to be b to the negative 7th. And then at this point, don't leave it with a negative exponent. Now flip it or move it down, however you want to think of it. So you end up with 36 over b to the 7th. Okay, and if you just want to see the other path I was talking about, I would probably move it down like that. So multiply them on the top, but then I would move down this b 10th and make it positive. And then from there, I would just see that, I got 7 more b's in my denominator than in the numerator. So that gets me b to the 7th in the denominator. Okay, so a couple different ways to do this one, but I kind of like this second path, to be honest. But if you want to do the rules, you'd start by adding those two to get negative 7. Okay, a couple more for you. Again, pause the video, give it a shot. All right, so this first one, there's no negative exponent, so I'm going to sort of expand it. So that 4, technically, again, the rule here is this 4 distributes to all that, but I'm going to write it out. Right? I'm going to write out that little thing 4 times. Right? That's really what that fourth power means. Okay, and then once we're here, now we have 2 times 2 times 2 times 2, which is really 2 to the 4th, which is what it would look like if you distributed the 4 in. So that's 16, and then x times x times x times x, that's x to the 4th. And again, like that's this x getting a 4th power distributed to it. And then here again, this is the power rule, so that's y to the 8th, which you can see visually here, right? Y squared, y squared, y squared, y squared, that's 8 total y's. That's y to the 8th. All right, second one here. My first gut reaction here is like, just don't even think about what's here. If it's to the 0 power, that's going to be 1, regardless of what's inside of here. Okay, so like all of that just becomes a 1. So we have 1 times w squared, and then that's just w squared. Okay, so all that thing cleans up to be just w squared. Obviously, there's other routes there, but to me, that's the cleanest or easiest. All right, again, I'm hopefully you're pausing these and trying them first, because I think that's going to be the best. That'll help you learn this the best. All right, so I don't even know. Where do we go from here? Maybe, I mean, the rule is you subtract the exponents here, like 5 minus 9 and then negative 3 minus 9. But maybe what I want to do is a slightly different route. I'm going to move down the negative exponent, and everything else stays put because they're all positive exponents. So just this y to the negative 3, move it down. Okay, and then from here, I'm going to combine these to be y to the 12th. Right, you add the exponents there. And then in my head here, I just think, again, on top I have x to the 5th, so that's 5 x's. X to the 9th is 9 x's. So they're just going to cancel out. We pair them up and cancel out, and you end up with 4 more x's in the bottom. Okay, so on here we just have 1 on the top left, and then on the bottom we have 4 x's, and we still have the y to the 12th. Okay, so this one cleans up to be 1 over x to the 4th times y to the 12th. Again, there's different routes there, but I like to think of it as expanded form, so that's kind of the route I would go. All right, again, pause the video, give this a shot. Okay, sometimes I try to clean up the fraction inside here, but that one doesn't clean up at all. So maybe what I'm going to think then is this 3 on the outside really means we have 3 little parentheses. That's what that 3 means. Okay, and then inside each parenthesis, we have an a squared on top, which is a times a. Okay, and then in the bottom, this 4 applies just to the b, so that looks like a 3 with 4 b's. 3 and then 4 b's. Okay, that's what it looks like expanded. Again, b to the 4th looks like that. Okay, and now I'm just going to go through and say up top, we have 6 total a's multiplied together. That's a to the 6th. And in the bottom, we have 3 times 3 times 3. That's 27. And then we have 4, 4, and 4. So that's 12 total b's, or b to the 12th. Okay, and that's it. There's our cleaned up answer. All right, keep on rocking. Pause the video. Give this one a shot. All right, so first part is this is not a negative exponent. That's not an exponent at all. It's just a regular number. So we're not going to move it down or anything. Okay, and then let's see. We could do expanded form, but this one's starting to look kind of nuts. So I'm going to just practice my rules here a little bit. Sorry to do them all a little bit differently, but I don't think that's bad to practice different things. So these are a distributive rule, sort of. So these little exponents on the outside get distributed. So we're going to have negative 2 squared, x squared, and then y squared squared. Right? If we distribute this 2 into each part there. And then in the back, we're going to have 2 squared x to the 4th squared, right? And then y cubed also gets squared. Okay, and this is all one giant multiplication. So at this point, -2 times -2 is 4. And then here's our power of a power rule. We have it a bunch of times. And the rule there is you multiply those exponents. So this will be a y to the 4th. This 2 squared becomes another 4. That's going to be x 8th and y 6 in the back here. Okay, now just do 4 times 4 is 16. And then x squared times x to the 8th is x to the 10th. Add those exponents now. And then y to the 4th and y to the 6th. Add those together, and that's y to the 10th also. Okay, so just to be clear on that last step, we multiplied these two 4s. That gave us the 16. And then combine the x's, combine the y. So 16x to the 10th, y to the 10th. All right, last one here. Pause the video, give it a shot. Okay, so here's my thought on this. So the 21 and -7 are regular numbers. That just divides to like -3 and 1. And then I'm just going to expand. So basically, here's x cubed, and there's x to the 1st. And what happens is they just cancel. Those just cancel out. Okay, so we have a -3 on the top at this point, and x squared is still up there. Okay, let's look at our y's. Right, we have a y to the 4th over a y cubed, and then cancel. So basically, we have one more y on the top than on the bottom. We have a y squared, or y to the 1st, sorry. And then for the z's, we have more z's on the bottom, actually. So when we do our z's, we have z squared up top. And then the bottom, we got z to the 5th. Looks like that. Okay. And now just cancel them out again. So cancel, cancel. But basically, we have 3 more z's on the bottom than on the top. Okay. And we still have this times 1. But really, the times 1 doesn't affect the question. So 2 more x's on the top. 1 more y on the top. Right. And then 3 extra z's in the bottom. Right. So that gives us this final answer like that. Okay, so that's a review of all the different exponent rules. All right, again, I use expanded form when I'm in trouble, except negative exponents. If you look back on these ones, the negative exponents, a lot of times I just move them first because then I can start to use expanded form to help me. All right, that's it. Thank you for watching. Have a good day.